In this lecture, we are going to discuss about the example on Cauchy residue theorem. This is the concluding lecture in the course Med DSC 351. Evaluate integral over c e to the power zt divided by z square plus 2z plus 2 dz when c is mod z equal to 3. Solution: we have fz equal to e to the power zt by z square plus 2z plus 2. Poles of fz are given by poles of fz are given by equating this denominator to 0. This implies either z square is equal to 0 or z square plus 2z plus 2 equal to 0. This implies that is 0 is a pole of fz is a pole of fz of order 2. This is a quadratic equation. Solve it by solving the formula for quadratic equation. If this is the quadratic equation, then the formula to solve this quadratic equation is x is equal to minus b plus minus root over b square minus 4ac divided by 2a, where a is not equal to 0. Use this formula to solve the given quadratic equation, that is z square plus 2z plus 2 equal to 0. We will get minus 2 plus minus root over 4 minus 8 divided by 2, that is minus 2 plus minus 2i divided by 2. This is equal to minus 1 plus minus I, which are simple pole of fz, simple pole of fz. So write z equal to 0 is a pole of fz of order 2, and z equal to minus 1 plus minus I are simple pole of fz, are simple poles of fz. Next, we shall find out residue of fz at these poles. First, residue of fz at z equal to 0. Then since z equal to 0 is a pole of order 2, then if z equal to a is a pole of order m, then residue of fz at z equal to a is given by limit z tends to a 1 by factorial m minus 1 differentiation with respect to z, m minus 1th order differentiation z minus a to the power m fz. Use this formula and find out the residue at z equal to 0 of which is a pole of order 2. Using this formula, we are going to find out the residue of fz at z equal to 0, which is limit z tends to 0 1 by 2 minus 1 d of 2 minus 1 dz 2 minus 1, then z square fz. This is equal to limit z tends to 0 ddz of z square e to the power zt divided by z square plus 2z plus 2. So this cancels out. Now find out the differentiation of this function e to the power zt divided by z square plus 2z plus 2. So differentiation of this function will be z tends to 0 e to the power t z t, then z square plus 2z plus 2 minus e to the power zt divided by 2z plus 2 divided by z square plus 2z plus 2 whole square, bracket close. If I put z equal to 0, then e to the power 0, e to the power 0 is 1, this will be t. This is 0, this is 0, this is 2. So first term will be 2t, 2t minus, if I put z equal to 0, then e to the power 0, 0 is, e to the power 0 is 1, this is 0 and this is 2. So this is minus 2 divided by 2 square, that is 4. That is, this is 0, this is 0, this will be 2 square, that is 4. And this is equal to here t minus 1 by 2. That is residue of fz at z equal to 0 is t minus 1 by 2. Next, we are going to find out the residue of fz at z equal to minus 1 plus I, as minus 1 plus I is a simple pole of fz. And we know the formula is z minus a fz limit z tends to a is a residue at pole z equal to a, at a simple pole z equal to a. So use this formula and check out what is the residue at z equal to minus 1 plus I. So limit z tends to minus 1 plus I, z minus 1 plus I f z. Now put the value of f z, that is limit z tends to minus 1 plus I. So z minus 1 plus I e to the power zt divided by z square, then z minus 1 plus I, z minus 1, this is minus I, okay, bracket close. This cancel out. We will left with limit z tends to minus 1 plus I e to the power zt by z square, z minus 1 minus I. If I put z equal to minus 1 plus I, then this is minus 1 plus I t divided by minus 1 plus I square. This is minus 1 plus I minus 1 plus minus I, okay, and this minus 1 plus I minus 1 plus I minus plus, this is minus I minus plus I square. So this is minus 2i minus 1, this is plus 1, this just cancel out. I will left with minus 2i. This square will be minus 2i and this will cancel out. So this will be plus 1 plus I plus 1 plus I. Okay, this is plus I. So this is 2I. This is e to the power minus 1 plus I t. This is equal to e to the power minus 1 plus I t. This is minus 4I square. I square is minus 1 into minus, that will be plus 4. Okay. Plus 4. That is residue of fz at z equal to minus 1 plus I is this one. Then I'm going to find out the residue of fz at z equal to minus 1 minus I. Okay, not plus I. Minus 1 minus I. So this is limit z tends to minus 1 minus I. Here this is z minus of minus 1 minus I fz. This is equal to limit z tends to minus 1 minus I, z minus 1 minus I e to the power zt, z square, z minus 1 minus I, z minus 1 plus I. The limit z tends to minus 1 minus I e to the power zt by z square, z minus 1 plus I. So put the value of z, we will get e minus 1 minus I t divided by z square. Z square is minus 1 minus I whole square, minus 1 minus I minus 1 plus I. This is equal to e to the power minus 1 minus I t. And this value will be minus 1 minus I plus 1 minus I. Okay, this cancel out, and this is minus 1 minus I minus 1 minus I. This is 1 plus I, this is plus I, this is plus I square. So this is 2I. This will be minus 2I plus 1. So this cancel out. This is equal to e minus 1 minus I t divided by 2I minus 2I. That is equal to e to the power minus 1 minus I t 4I square, that is 4. So this is the residue when z equal to minus 1 minus I, and this is the residue when z equal to minus 1 plus I. So by Cauchy residue theorem, Cauchy residue theorem, integral over c fz dz equal to 2 by I residue of fz at pole. Sum of the residue of fz at pole. Here is pole of fz are this. So residue of fz at z equal to minus 1 plus I plus residue of fz at z equal to minus 1 minus I. Now put this value, you will get This implies integral over c e to the power zt dz is z square 2z plus 2, and there is one z square also. This is equal to 2 by I residue at z equal to 0. Residue at z equal to 0. T minus 1 by 2. T minus 1 divided by 2 plus residue at z equal to minus 1 plus I e to the power minus 1 plus I t by 4 e to the power minus 1 plus I t by 4 plus a residue at z equal to minus 1 minus I. This is the residue e to the power minus 1 minus I by 4. With this, your paper Math DSC 351 is completed. Okay, you should practice lot of questions. You should practice lot of questions. You should practice all the solved questions of your textbook. You should give revision of 2 to 5 year previous year question paper. In case of any problem, any difficulty, you can ask me. With that, I would like to conclude. Thank you.